Hello, Year 8. So this is lesson 4 of our computer systems unit, and today we're going to be talking about logic gates. As an opening task, there is a worksheet, the A0 worksheet. I don't want you to spend more than 5 minutes on this, so even if you don't get to the end of it, do 5 minutes and then just stop. But what you've got here, you get, if you open a browser window, you can visit, there's a link here. So you're already in a browser with a worksheet open, and you're presented with this. This is the Turing Tumble, but this is the online simulator. And you can, what this does is it shows you that you've got this activation where the balls come down, and this cog is considered the input, and this one is considered the output. So if I set the input to point to the left and release a ball, let's see what happens. The output ends up pointing to the right. If I set the inputs to the right and do another activation, nothing happens. Try again. Okay, I'll try that way. The input was to the right, the output's to the left, and so you're going to capture the behavior of this in this worksheet. So just write down kind of where it was pointing, and then say what's happening. And then you basically just go through, there's a few different circuits to look at. The Turing Tumble is quite a good analogue of real computers just because it's quite a mechanical mechanism. So 5 minutes on that worksheet and then move on. Right, so we're looking at Boolean logic and logical operators and logical expressions, and we're going to be creating logic gates, logic circuits using gates. So this is Boolean logic is named after George Boole, who wrote a book about the laws of thought, but it was all about reasoning and mathematics and how they can be applied to logic. So arithmetic operations like addition, you've seen this kind of thing in maths since primary school. I can do like 7 plus x, and I've got like a constant, I've got numbers, I've got letters, things that can be named later. And the operators are like your plus, minus, divide and times. Well, logical operations can be done using ands, ors and nots, and they look a bit like this. On the right hand side I've got A and B, and so if A and B are true, this expression will as a whole result in the value true. So you're going to see a few of those applied to kind of real world examples. So the three operations are not, and or, and believe it or not, all you need is an absolute ton of those to make a computer. And I mean a computer in the full sense of it. So here's a sort of real world example. I'm going to go out if it's not raining. And so the output, the go out, that's almost like the output variable. Raining is the input variable. So I'm going to evaluate raining. If raining is false, then not raining is true. If raining is true, then not raining is false, and therefore go out is just equal to not raining. So this thing on the right hand side is a truth table, and you're going to see quite a few of those. Here's another one. I've now got a motion sensor and an activated, whether the system is actually activated or not. For a security system. So if the system is activated, like I've left my house, I've activated my security system, and motion is detected, I will open this is an automatic door actually, not a security system. So if the automatic doors are activated and it detects motion, it will open the door. And this is using AND. So both of the inputs need to be true for the output to be true. So here's a truth table that shows that. If motion is false, activated is false, then it will open is false. If one of them is true but the other is false, it still won't open. Only when both are true is the output true, and that's the AND gate. And then an OR gate, if I have left or right, if I've detected movement to the left or the right, I'll open in either case. And so if they're both false, open is still false. Left or right is false. But if only one of them is true, well, the output's true now because I'm using OR instead of AND. So you've got a worksheet, the A1 worksheet, And what you have to do is you're filling in truth tables. So it's going to give you like task 1, it's going to describe a scenario, and then you have to think, well, if light sensor reading light is false, what is the value of not light? To help you with that, I have attached to the classroom a circuit verse demonstration of this. If you open this up, it should present you with something like this. And each of those A1 worksheets, if you click on the task, you can actually see a circuit that replicates what's going on. So light, if it's off, output's on. If the input's on, output's off. And I've done that for all of them. So you can play around with those and basically record the values in the truth tables all the way through. Once you've done that, I'll go skip over the solutions. So with the so why is this important? Well, true and false can be represented by switches that are either on or off, and this is kind of the fundamental thing with computers. They're just built from a huge number of switches, and so this is kind of showing you how those things could be represented, like motion and activated, as switches that are on or off. Obviously there's like sensors behind the motion one, which are going to output off or on according to whether it's detecting motion. Similar with the left or right. And so you're going to see these are the logic circuit icons that you will see in Circuitverse. So you can see this is a NOT gate with the like sort of triangular thing with a dot on it. This is an OR gate. This is an AND gate. And then I've got an AND gate and a NOT gate in combination for that Explorer task. And so you're going to be playing around with those. And here is how you might draw, like I've got an input raining and it goes through a NOT gate. So go out equals not raining. Same things we looked at before, but now we're looking at them as circuit diagrams, because you can build circuit diagrams up and up and up until you've got more and more complex things. And I said eventually you get to a computer. So the next worksheet, the A2 worksheet, you are actually going to open Circuitverse yourself, and you can just log in with Google. So what I'll do, I will sign out to demonstrate that. If I really, please do sign out. There we go. If I log in, I can actually log in with Google, and then you've got an account on this thing. I'll pick my account. Launch simulator. And then you can start dragging on the symbols. So I've got like inputs, I've got outputs, I've got different gates, and you can search for the things up there as well. So the instructions here explain exactly what to do. So go through the A2 worksheet and do as much of that as you can, and you should end up filling in the truth tables. If you want, save your project, and you could actually share the project. Where do we do that? I'll tell you what, I'll open one of the ones that I have got already. There we go. So if I'm in here, you could literally copy this URL from the top here and add it to the classroom so that I can see what you've actually managed to build. So yeah, do that worksheet. And then let's come back. So you're just getting actually to play around with logic circuits. I'll skip over the solutions. So we can build components from these logic gates. CPUs, the RAM, SSDs, they're all just logic gates. And we visualize them as switches because they can be on or off, which we can also represent that as zeros and ones, which can then be just combined to form binary numbers. And so, as we will see through the year, this is why binary numbers are such a fundamental part of computing. Here are some examples of more complicated circuits. You can actually go to the link and play around with that one if you want, once you've done the worksheets. And then here are some ones that do binary addition. Obviously we haven't taught you how to do that yet, but you can play around with these and see how they behave. I actually quite like the idea that even just with that, you're already starting to get to adding numbers, already getting to concepts you would actually recognise. If you've got time in the lesson, get to the homework, and some of this is sort of a recap of what we've done in the lesson there with the truth table, with a more complex statement. And then in here you've got a word fill, which is largely based on the work we've been doing up to now. So again, you're picking a word to go in each gap. So the word performed by the computer is specified by a 1. I guess that will be program. So program might be 1, but check the other 1 in here and make sure that that makes sense, and just work your way down through those. And just follow the instructions. attach any circuits that you've made, and that should be a good one. So quite a lot of good stuff to play with. I hope you have fun with it, and I'll see you next week.